Hi, this is Alex and Joyce from Teaching Growth, and this is our teaser for our logarithmic and exponential function video. If you want the full video, please visit our YouTube channel to get some more content and better explanation into these two functions, or better yet, you can attend our center where we have one-on-one tutoring opportunities.
So for this teaser, to introduce the idea of an exponential function, we are going to be going over a problem that a teacher might commonly ask, which would be to draw and identify the attributes of the following exponential function. And the exponential function that we are going to be using is f of x is equal to 2 to the x power. So an exponential function, f of x equals to the 2 to the x power, will look like this. So next thing that we're going to be going over is identifying the attributes of this function. So the first attribute that we're going to identify that's not listed actually is going to be asymptotes. So exponential functions have asymptotes, and the parent function of the asymptote will be across the x-axis like here, and this is what we call a horizontal asymptote, and this horizontal asymptote is located at y equals 0. So the next attribute that we're going to be discussing is maximum, and the maximum for this exponential function is not going to exist, so we're going to write dne. However, we can also write infinity as an answer. And the minimum for this is going to be simply 0. So the next thing we're going to be going over is domain and range, and starting with range, the range of this function is going to be y is greater than 0. And the domain of this function is that x belongs to a set of all real numbers. So next thing that we're going to be talking about, or the next attribute, is symmetry. And for symmetry, we can simply write none, because this function is not symmetrical to anything at all. And the final set of attributes we're going to be going over is x-intercept and y-intercept. So intercept is where the function crosses across one of the axes. So we are actually not going to have an x-axis. So we're going to, or x-intercept, I'm sorry. So we're simply going to write dne does not exist, or we can write none. That's an acceptable answer. And for the y-intercept, we're going to have a y-intercept at the coordinate 0, 1. These are all the attributes, and this is what an exponential function will look like. If you want to get more information, you can check out our YouTube channel.
So we're going to continue this trend and we're going to do the same exact problem, but for the logarithmic function, because teachers really want you to identify attributes of parent functions, and they're important to know in order to have a base understanding for everything that comes afterwards in Algebra 2. So what does a logarithmic function looks like? Well, a base logarithmic function will look something like this. Now, what is the maximum value for this logarithmic function? Well, the maximum value is going to be, it doesn't exist, or sometimes referred to as infinity. And the minimum value will be it doesn't exist, or negative infinity. Now, for the range of this function, it's actually unbounded, so it'll be y is a subset of all real numbers. Meanwhile, though, x is bounded, and we'll talk about why it's bounded in a second really quick, and x is going to be everything greater than 0. Okay, now the reason why x has to be greater than 0 is because we actually have something special here called an asymptote at x equals 0. Right here, there's an asymptote, and the logarithmic function will approach this and never reach x equals 0. But it will start to approach y equals infinity if you do take that limit, which you'll learn soon in pre-calculus, I'm pretty sure. Now, symmetry-wise, the logarithmic function is not symmetrical about the x, y, or about the origin, so we can write it doesn't exist for this. And for the x-intercept, it is at 1. It is always going to be at 1, or more specifically, x equals 1, y equals 0. It'll always be here unless there's a shift in the function, which we'll talk about in later lessons. And the y-intercept doesn't exist, as the function never crosses the y-axis. Now, I went over these really quickly, and I'm sure you probably want an explanation into how I found the maximum, minimum, and some deeper explanation into the intercepts and even the range and domain. So if you want to learn more or even get a one-on-one tutoring session, visit the Teaching Growth Center itself, our website, or our YouTube channel to get the full video and full explanation. Thank you for watching.